Hello, we are from Group 1. We will explain about fault analysis, and this is the data that we use. And this time we will learn to use the DIPS application for structural analysis. Okay, here are the data on shear, gas, and brecciation. And first, we just copy the shear data first, and then open the DIPS application, open the file, click New, then click Setup, click Job Control, and change it into DIPR. Why is the strike/DIPR? Because our DIP is to the right of the strike. Then we paste the data from the shear data. And next, we copy the gas data and then paste below the shear data. Click the contour plot and be like this. After that, we will get the shear and gas plane. And next, we click the add plane. And then click on the top of the contour in the red one. Like this, and label GF as a gas fracture. After that, we add another plane for the SF, like this. And then label it SF as a shear fracture. And next, if you have used the contour, let be simpler, we click on the major planes plot and it will turn out like this. Okay, next continue to create auxiliary fields by way of uplinks again. Right the cursor between the intersection of SF and GF like this. And then continue given a description of the auxiliary fields, SPP.
Then we will plot the fault plan, so this field is obtained from the original breccial data. Why is it 19 here? Because the original data breccial is the direction of the dip is 90. Then copy and paste it in the table in the dip application. Then using a Ross diagram and found a general direction between 20 and 30. Then take the middle value, which is 25. Then return to the major plan plot. Create a fault plan that cuts through the intersection of GF and SF and has a direction 25. Then the fault plan description is given. Because there is a lot of writing, we can remove it by editing the plate and then clicking on one. You can choose your own color in here to describe each line. After that, we will define Tau1 to Tau3 accent. We will use the add pitch grid. It will appear like this. So this pitch grid just make it easier for us. So we can pin plot on the help area for the grid pitch, then click OK. After that, we add a line using the draw moving line. The absolute accent Tau1 for the GF slice and auxiliary plane, then click OK. And given the text, we can give the text outside the line. After that, can give Tau1 30 degrees from Tau1 accent. We click OK, then given the text. Then, the accent Tau3 90 degrees from the Tau1 accent. Then given a statement Tau1 Tau3 accent. After that, Tau3 is 90 degrees from Tau1. For Tau2, the accent from the center to the intersection of SF and F and GF. Then annotate Tau2.
After that, it requires net slip. It is from the center to the intersection of the fault plane and auxiliary plane. So draw a moving line again and add net slip and give net slip text. After that, it requires the direction of movement of the fault. The direction of movement of the fault is seen from the fault plane with vector gas. It can be seen that if it from an acute angle, the arrow will be in, and if it's blunt, then the arrow is out. And here it turns out that it from an ob- obtuse angle, so the arrow comes out. Then give the arrow using the add arrow. So to draw the arrow, it has to be from the tip of the arrow, and then add another football. And you can see the link slip of the movement of the fall to the right, but the lens slip of it support the outside, so you can add an arrow and go down. After that, write the value of its field and open Excel. For editing, can click Edit Plan. To read net slip and affirmation, use trend and plan in the lower right corner, and after that it can be saved and can be read in the lower right corner. To calculate the rate, you can use the measure angle, then click on the intersection of the stray plane and the auxiliary plane to the intersection of the outline and let slip. Then, to name the fault using the Ricard classification, 1972. Hmm. To read it, can use a tip from the fault and use the rig. So, as you can see here, the data is on number 11 in Ricard scale, and the name of this fault is normal right slip fault. And if it can be exported to image, and the result is like this.
Okay, so this is for 3D fault analysis. This is the representative of the fault shape. Okay, thank you for your attention. Goodbye.
Goodbye.